I'm a software engineer for CloudBees Core for Modern Platforms, and I am here to discuss a little bit of notes about storage in Kubernetes and why it is important for CloudBees Core. Um, so first off, why CloudBees Core needs storage. I don't have much to show on this other than you can see how to set it. But it needs storage because Jenkins, which is run as part of CloudBees Core, stores its configuration, its build logs, all sorts of other information, artifacts possibly, on a storage that it thinks is local. It is mounted on the same system as Jenkins is running on. We refer to that as Jenkins Home. So lots of stuff gets written and read from that little piece of storage all the time. In Kubernetes, you provide a volume. This is volumes, these volumes in Kubernetes, this is the ephemeral volume that is part of a pod. Persistent volumes are what we actually use for CloudBees Core Operations Center and masters, managed masters. You create a core PVC, a persistent volume claim, either in the YAML or when our Helm chart applies. There's a lot of options for them. The important thing, though, is the storage class, which these are the types. You can see here that Kubernetes has listed as being supported. There's also this list, which lists storage classes that are supported. It is very important that the storage class used with CloudBees Core be of an SSD class, not magnetic storage. Magnetic storage just simply is not fast enough to keep up with all the reads and writes that Jenkins is doing. So typically we would define in GP2, I believe, the AWS is kind of the example, and it's the one that I know the best. So we tend to use GP2 storage class in AWS. And that can be provisioned either as EBS or EFS. The thing that's important to know about that, and I believe this is true on other cloud providers, is in Amazon, EBS is not multi-availability zone. So if you have an EBS volume, which is kind of what we recommend most of the time because it's the easiest to set up, it will not be available in other availability zones unless you actually make snapshots of it and copy them there yourself. The alternative is to use EFS, which is multi-availability zone, but has to be mounted as an NFS mount. So when you are looking at your storage classes here, it would be an NFS type, which unfortunately they don't provide a config example for, but I believe we do. In fact, I know we do. It's on this page that I was just showing. So the client provisioner and how to use NFS as your storage class. Let's see, where was I? So it would be great if we could set some sort of EBS's, or not EBS, SSD class as the default in all of the settings and in all the cloud providers. I know that Azure doesn't allow you to override the default. So you have to specify a storage class all the time in anything that you're doing in Azure. So that's another important thing to note if you're building in that cloud. I know that both, I believe AWS and Google's clouds provide magnetic storage as the default, which is not sufficient, as I said. Let's see. You should, yeah. when setting up the CloudBees, ah, so when setting up your cluster, your initial setup of the Kubernetes cluster prior to installing CloudBees Core, one of the things you will do is you will define the nodes um, that make up the cluster, and these nodes are what everything runs on. Now, um, Operations Center and the Managed Masters will have a storage class in their definition, so that they will be use those persistent volume claims, and those will be of that storage class. Now, build agents don't have persistent volume claims. Build agents use the ephemeral storage that's available on a pod. Um, and that's going to be whatever the storage is that's defined on the node that the pod runs on. So you want SSD storage on all of your nodes in your Kubernetes cluster. Otherwise, your builds are going to be run on Kubernetes agents that are running on magnetic storage. And if your build is at all IO heavy, it's going to be very slow. So it is important to everywhere set up SSD storage. And as we recommend, two things about the storage: it needs to be provisioned, not burst. Um, I know it is more expensive to have provisioned storage, but we have had troubleshooting problems time and time again where customers have not had provisioned storage and they have run out of burst credits before the month is up, and Jenkins slows to a crawl because you're suddenly at the mercy of however fast your cloud provider wants to let you go when you don't have any burst credits. CloudBees has tested and recommends a throughput of 160 megabits per second. That is what we think is kind of the minimum to have a performant cluster of CloudBees Core, Operations Center, and Managed Masters. And yeah, the one last thing that I have discovered is a good testing tool. It's in GitHub. It's called Smallfile. And you can, when you're working with a customer who has set up their own storage, most likely this is going to be like someone who's doing an on-prem Kubernetes. The way I would do this, and I have done this for testing in the past, is create a VM that's in the same cluster that uses, so that it can mount the file system that they're mounting, whatever, probably NFS, although it could be like GlusterFS or something like that, or Ceph. So create a VM that can mount that file system and use this tool to test its throughput. It's it's a Python tool. It's fairly simple. Just takes a little while, and it will throw files all over the place and read and write them, and it will tell you this data transfer rate that you need to know. If it's not getting to 160, that could be a problem. I think that pretty well covers most of the concepts of storage, I hope. So good luck, and remember, no magnetic storage. Magnetic is bad.